All right, so for this video, you're not going to be seeing my beautiful face, but you will be hearing my beautiful, possibly slightly annoying voice. So we are on the fifth lesson of our trig unit, and in this lesson we are going to be looking at the unit circle a little bit more. So first things first, we are going to fill out this table in the do now. Remember, this table is super important, okay? It's important that you memorize these values of sine, cosine, and tangent. But to help you memorize them, there are patterns and tricks. So first, the pattern for 30, 45, and 60 are different than the pattern for 0, 90, 180, 270, and 360. So I'm going to do that last. So first we're going to start with sine of 0. Sine of 0 is 0. Cosine of 0 is 1. Tangent of 0 is 0. You have to remember those three values because they will help you with the rest of the pattern. So now we're going to look at sine. So the pattern goes 0, 1, 0, negative 1, and so on. So we start at 0. So we're skipping that middle section and we're going to 90. The next value is going to be 1. So sine of 90 is 1. Sine of 180 will be 0 then. Sine of 270, negative 1. And sine of 360, 0. So there is the pattern, 0, 1, 0, negative 1, 0. Cosine follows the same pattern, but it starts at 1. So it goes 1, 0, negative 1, 0, 1. Now, tangent's pattern is slightly different. It goes 0 and then undefined, 0, undefined, and 0. Okay? Sorry if my handwriting is going to be a little sloppy in this lesson. It's my first time trying to use a stylus pen to write on an iPad. So let's now do the 30, 45, and 60. So these, for sine and cosine, this follows a 1, 2, 3, 3, 2, 1 pattern. First things first, everything is going to be over 2. So I'm going to start with that. And now let's look at our 1, 2, 3, 3, 2, 1 pattern. Starting with sine, we have 1, 2, 3. And then for cosine, we have 3, 2, 1. Now to find what tangent is, it's slightly different. If you look back at the last video, we found tangent of 30, 45, and 60 by using tangent of theta equals sine of theta over cosine of theta. If you would like to look more into that, you can refer back to the last video. But if you were to use that ratio, the tan of 30 would give you 1 over rad 3. The tangent of 45 will give you 1. And the tangent of 60 will give you radical 3. So this table is going to be very important, and we are going to be referring back to it later on in the lesson. So let's start with what a unit circle is. The unit circle is a circle on the coordinate plane that has a radius of 1. The radius could be anywhere on the circle, but it is important that when it is on a unit circle, the radius is 1. This is important because in our last lesson, when we would make a triangle from a point on the circle, the hypotenuse would be 1. So on a unit circle, the hypotenuse of a triangle, well, of a right triangle, would be 1. So let's recall the quadrants in which the trig ratios are positive. So first let's label our quadrants. We start at the top right, that is quadrant 1. Then we go counterclockwise. So then we have 2, 3, and 4. So to figure out which are positive, we use all students talk constantly. We start in quadrant 1. So we have an A in quadrant 1 that represents all trig ratios are positive. Then we have S, which represents that sine and its reciprocal are positive. Then we have T, which is tangent and its reciprocal. And then we have C, which is cosine and its reciprocal. So what we're going to do here is we're going to find the sine and cosine of the coordinate point x and y on a unit circle. So x and y, they're both positive. We don't know their numbers though. So it's just x and y like this. So to find the sine and cosine, since we have a point, we connect the point to the origin, and then we drop a line down to the x-axis, complete our triangle, and we have our right angle. This distance here is x. This distance here is y. And since it is on a unit circle, our hypotenuse is 1. So now let's find the sine and the cosine. So the sine of theta. Theta is always made from the x-axis to the hypotenuse. So there is our theta. To find sine of theta, we use SOH, CA, TOA. Sine is over here, which is opposite over hypotenuse. The opposite of theta is y. The hypotenuse is 1. Y over 1 is just y. So we have sine of theta is equal to y. Now let's find the cosine. So cosine of theta, to find that, we use CA. So we use adjacent over hypotenuse. The adjacent side is x, the hypotenuse is 1. So we get that cosine of theta is x. This is really, really important, that the sine is equal to y and the cosine is equal to x. So on a unit circle, this fact is going to help us. So whenever you see that we have a unit circle, remember that the x-coordinate corresponds to cosine and the y-coordinate corresponds to sine. So let's look at some special points on the unit circle. So some special points on the unit circle include 0, 30, 45, 60, and 90. Notice those are the points from the table that was in the do now. Now we're only looking at the first quadrant here, but the same will apply for all of them. If you just want to see what the value would be in another quadrant, you just use all students talk constantly. Now I want to look at 30 for a second here. So we're going to look at 30. It says that the coordinate for 30 is radical 3 over 2, comma 1/2. This is telling us that we have the cosine of 30, comma, the sine of 30. Sorry, that is supposed to say 30. If you refer back to the chart, the cosine of 30 was radical 3 over 2, and the sine of 30 was 1/2. That's how they got those values there. And the same applies for all the rest of them. So those special points actually come from our special right triangles if you wanted to know where they come from. To find the exact value of a point on a unit circle, first you have to determine what quadrant the angle falls in to determine if it's positive or negative. Then you're going to find the reference angle. The reason why we find the reference angle is because we want the angle to be one of the values from our chart. Then we have to find the cosine, which is the x value, and the sine, which is the y value. Again, using the chart that we've been filling out, and answer whatever question it's asking us. So it says, find the exact value of tangent of 300 on a unit circle. Since it's on a unit circle, that's why we use the process that we are using. So let's start by figuring out where this angle is. So we have our coordinate plane. This is 0, 90, 180, 270, and 360. Our angle is 300 degrees. 300 is somewhere over here. If we were to label the quadrants, it is in quadrants 4. Since it's in quadrant 4, to find the reference angle, if you want to refer back to how to find the reference angle, go back to lesson 1. To find it in the 4th quadrant, we do 360 minus theta. In this case, we have 360 minus 300, because that is our angle. 360 minus 300 is 60 degrees. So 60 degrees is our reference angle. Next thing we should do is find the sine of 60 and the cosine of 60. This will tell us our x and our y coordinate. So again, you're going to refer to the table in the beginning for this one. The sine of 60, this was equal to radical 3 over 2. The cosine of 60 is equal to 1 over 2. The question itself didn't tell us to find the sine or the cosine. It told us to find the tangent. So to find the tangent of theta is equal to, let me just move that over actually so I have some more space to write. Tangent of theta is equal to the sine of theta divided by the cosine of theta. So the tangent of, we can find the tangent of 60 because remember the reference angle and the regular angle have the same trig values. So this should be equal to the sine of 60 divided by the cosine of 60. And we have those values right here. The sine of 60 is equal to radical 3 over 2. I'm going to divide this by the cosine of 60, which is 1 over 2. Keep, change, flip. So we keep this, change to multiplication, and flip that. Now the 2's will cancel, and we are left with radical 3 as our answer. Now keep in mind for this problem specifically, you didn't have to do all this work if you remembered the tangent of 60. All right, find the exact value of cosecant of 120 on a unit circle. All right, let's figure out where 120 is. 0, 90, 180, 270, 360. So 120 is going to be somewhere over here. Okay, so this is in quadrant 2. Since it is in quadrant 2, we need to use this rule in order to find the reference angle. So 180 minus theta. So for 180 minus theta, we have 180 minus 120. And 180 minus 120 gives us 60. So since we have 60 degrees and we're looking for cosecant, cosecant is the reciprocal of sine. So really the only value that matters for us to find right now is the sine of 60. So the sine of 60, think back to the chart from the beginning, is going to be radical 3 over 2. So that tells us that the cosecant of 60 will be the reciprocal of this, so you just flip them around. So that will give you 2 over radical 3. Now I am going to refer back to the last problem for a second. There is one thing that I did forget. So we have to do all students talk constantly to figure out if this answer will be positive or negative. So this should be all students talk constantly. Since the angle ends in the fourth quadrant and we are finding tangent, this should be a negative value. So in this one, again, if we use all students talk constantly, so all students talk constantly, this ends in the second quadrant where sine and cosecant are both positive. So our answer here would be 2 over radical 3. Now, just to do a little bit of review, if you want to rationalize this, you can multiply the numerator and denominator by radical 3. So you would get 2 times radical 3, which is 2 radical 3. And radical 3 times radical 3 is just 3. So this is if you were to rationalize. This is your rationalized answer. Okay. Moving forward. It says the terminal side of angle theta passes through the point negative 1 over 2, comma 3 radical 2 on a unit circle. Now, we did a problem almost exactly like this yesterday, and you're going to see how this fact, x comma y, is cosine theta comma sine theta, is going to help us so much. All right? Now, in this problem, they give us the point negative 1 over 2, comma, radical 3 over 2. This tells us that 1 over 2 is cosine of theta, and radical 3 over 2 is sine of theta. So we already have 2 of our trig ratios done. So sine, I'll just rewrite it in a different color. So we have sine of theta is equal to radical 3 over 2. Cosine of theta is equal to negative 1 over 2. We have to do no other work than that. Since we have sine and cosine, we also have cosecant of theta and secant of theta. Cosecant of theta is the reciprocal of sine, so you just have to flip over that fraction. So it becomes 2 over radical 3. Same thing applies for cosine. Just find the reciprocal, which is negative 2. The only one that's going to require a little bit more work is going to be tangent. So I am going to write tangent a little bit above. So the tangent of theta, to find tangent, we use sine of theta over cosine of theta. Okay, so we already know the sine and we already know the cosine. Since they are both fractions, to write this, I'm going to write the sine divided by the cosine. I'm only doing this for notation purposes. So to find that, we do radical 3 over 2, we keep, we change, and we flip. So when this happens, the 2 and the 2 cancel out, and we're left with negative radical 3 for the tangent of theta. To find the cotangent of theta, you just take the reciprocal. So instead of negative radical 3, you can write it over 1. It's going to be negative 1 over radical 3. So we did do a problem like this yesterday, and it required a lot more work than this. So if you notice that you do have some point on the unit circle, I would highly suggest to use this rule. Okay, we're going to do one last problem. It says find the exact value of cosine of 5 pi over 4 on a unit circle. Now, we don't know what 5 pi over 4 is exactly. So first thing we're going to have to do is convert this from radians to degrees. To convert from radians to degrees, you have to multiply this by 180 over pi. So when you do this, the 2 pi's, since one's on the top and one's on the bottom, they cancel out. And then you can open up your calculator to see what this will simplify to give you. So first things first, we have to do 5 times 180, and that gives us 900. And then we have 4 on the bottom. 900 divided by 4, that gives us 225. So this is equal to 225 degrees. So what we're really trying to find is the cosine of 225 degrees. So first let's figure out where this is. So we have our little quadrant, 0, 90, 180, 270, 360. Now, 225 is going to be somewhere over here. Again, we don't know exactly where, that's okay. So this is going to be in the first, second, in the third quadrant. Since it's in the third quadrant, to find the reference angle, we have to do theta minus 180. Our theta is 225, so we do 225 minus 180. You can go to our calculator. 225 minus 180. That gives us 45. So we have to find the cosine of 45. We know this though from our chart before. The cosine of 45 is radical 2 over 2. Now what we have to do is figure out if this is positive or negative by using all students talk constantly. Since it does lie where t, which is tangent, is positive, that tells us that our answer should be a negative number because cosine is negative in that quadrant. Okay, in order to get credit for today's lesson, you must complete this problem on a separate sheet of paper, take a picture of your work and your solution, and post it onto Google Classroom.